Now, students, we have seen the purely capacitive circuit and we have also drawn the conclusions that we can get from the equations that we have obtained. Okay, so students, let us draw the purely capacitive circuit once again, and today we will discuss the power that is generated in the circuit. Okay. Okay, so this is your basic circuit. Here the alternating voltage is applied. In this direction the current is flowing. Here is your capacitor. Alright. Okay, so now students, we will see that what is the power in the circuit. Students, can you see from the equations that we have discussed in the class that the phase difference between the voltage and the current is minus 90 degree. Phase difference between voltage and current is theta equals to minus 90 degree. Okay. So, hope you have remembered the power factor that we have discussed. So, your power factor, that is cos theta, will be equal to 0 because as your theta is 90 degree minus 90 degree. So, your power factor, that is your cos theta, will be equal to 0, isn't it? Because cos 90's value is 0. So, therefore, you can say that the power consumption will be 0. So, what is the equation of the power consumption that we write? P equals to half V naught I naught cos theta will be equal to 0 because this your cos theta part is 0. So, full thing will get 0. So, your power will be 0. So, therefore, this particular current is wattless. That means this particular circuit is wattless. Okay. Okay. Now, students, we will learn about the ideal current or the wattless current. Okay, very important for your 2 marks question, students. This can be asked in the exam. Okay, so the power consumed in an AC circuit is what? P equals to this equation, P equals to half V naught I naught cos theta. This is the equation for the power. So the power consumed in general case. In general case, students, the power consumed in the AC circuit is this. Okay, for the general case. So now the phase difference between the voltage and the current in a pure inductive circuit is theta equals to 90 degree. Go back to the case of the inductive circuit, purely inductive circuit. What we have learned that the value of the theta will be 90 degree. Understood? So the power between the voltage and the current in a pure capacitive circuit is your this theta equals to minus 90 degree. Understood? First what we are doing. First we have to write the general equation for, I'm writing it here. The general equation for the power consumed, I'm writing power consumed in an AC circuit is P equals to this part half V naught I naught cos theta. This is general equation. Now students, you have to recall the phase difference between the voltage and the current in the case of the purely inductive circuit. What is the value of that voltage? What is the value of that phase difference? The value of phase difference is your 90 degree. I'm writing it here. For inductive circuit, phase difference, I'm writing that just as theta equals to 90 degree. Understand? So the power in this particular circuit is 0 for the case of this inductive circuit, because your theta part is 90 degree. So cos theta, when theta equals to 90 degree, that means cos 90 degree is 0. Understood? For the case of this purely inductive circuit. And the same ways for the purely capacitive circuit, your theta part is minus 90 degree. So again your power value will be equal to 0. It means what conclusion we can draw from the two respective circuits? From the two respective circuits, students, we can say that in the case of this purely inductive or the capacitive circuit, it doesn't dissipate any power or current through the inductor or the capacitor. Hence, it is called as the wattless or idle current. Understood? That means both circuits, okay, whether it is an inductive or the capacitive circuit, it doesn't dissipate any current. So that therefore your particular circuit will be your wattless or idle current. Understood? Okay. So nearly we have completed this purely capacitive circuit. Now we will move to the LR circuit. Okay. So just students, LR means, students, what? There will be the presence of both your L, that is your inductor, and the R, that is your resistor. Okay. Just let us draw. I'm writing it here. LR circuit. Let us draw the LR circuit, students. How to represent this L, that is your inductance, by this way. Understood? This is your L. Understood? And the resistance part, you know, that is in this way. No need to show. Okay. So I am mixing up this, I'm just putting these two things here. This is your L part, this is your R part. Understood how to draw the diagram for the respective circuits? It's very much important, students. Without diagram in the exam, you will never get full marks. I told you many times in the class also. This is your L, this is your R, okay, and the direction of the current also I have shown you all, and this is the value. Okay, I'm just writing it here for now. This is the value of this VL, that is the voltage drop across this inductor, and the voltage drop for across this resistor is VR. Understood how the circuit diagram will look like? Okay.